Hello guys, Mr. G here, and we're going to be making a video now. We're going to make a few videos related to stoichiometric to understand a little bit. This topic can be confusing, it can be difficult, so let's go on and see how we can make it very easy to understand. So the first definition we're going to look at is the mole, and it's one of the most important definition. Okay, now the mole is the SI, or Standard International Unit, for amount of substance. So the mole is the Standard International Unit for amount of substance. Note, this is not the definition of the mole. This is what the mole is. It's not the definition, okay? Now, the symbol for the mole is going to be just MOL. This is the symbol for the mole, okay? Or the abbreviation for the mole is the unit, and the symbol for the mole is going to be the symbol we're going to be using is going to be little n. So that is the mole, and this is the unit. The unit. Now, their definition for the mole will be the mole is the amount of substance having the same number of particles. Now, we are going to highlight number of particles as there are atoms in 12 grams of carbon 12. What do they mean by number of particles? That could be atoms, it could be molecules, it could be ions, it could be electrons, it could be atoms. Okay, so those are the particles we are talking about. Okay, so this is the definition for amount of substance. So if in equation they say define amount of substance or define the mole, this is the definition. Okay, so far we know that the symbol for amount of substance of the mole is going to be m, and the unit is going to be a mole, the abbreviation for the whole word. Okay, so that is the first part of the video. Now we're going to a second very important definition, and this is going to be Avogadro's number. Okay, so now Avogadro's number is the number of particles, and then we are referring once more at this number of particles. Is the number of particles, could be atoms, could be ions, could be molecules, could be formula units that there is in a mole. So one mole of any substance will have a specific number of atoms, molecules, ions, formula units, etc. Now, the Avogadro's number symbol is going to be capital N and A, and the number of particles we are talking about is 6,022 times 10 to the 23. That is Avogadro's number. So one mole of bread, for instance, will have these numbers of bread particles. One mole of water will have this number of water molecules, because water is made of molecules. So let's see that example real fast. For example, we have three different substances. We have sodium. Sodium is made of atoms. We have water. Water is made of molecules. Now, no, the molecules are also made of atoms, but we are making the main particle in each of them. And sodium chloride, or table salt, is made of formula unit. Okay, you can watch the video I made on bonding, and you will understand better this part of atoms, molecules, and formula units. All right, so we say that in one mole, we say that in 1 mole of sodium, there will be 6,022 times 10 to the 23 atoms. Atoms of sodium, we're talking about sodium. In 1 mole of sodium, there will be 6,022 times 10 to the 23 atoms. And therefore, 1 mole, and I'm not going to write off, 1 mole of water, H2O, will be equal to 6,022 times 10 to the 23 molecules of water. Molecules of water, that don't have a space, so I'm not going to write it. And then 1 mole, same, of NaCl will be equal to 6,022 times 10 to the 23 formula units. Okay, so that is very, very important. In 1 mole of any substance will be this number of particles of that specific substance. Okay, so this is the first part of this video we're making now. Now we're going to another definition. Now this definition is going to be another very important definition. Alright, so molar mass is the mass of 1 mole, of substance. So if you take 1 mole of sodium chloride, that is going to be called molar mass. If you measure the mass of 1 mole of water will be called molar mass of water. Alright, the mass of 1 mole of sodium will be called molar mass of sodium. The symbol for molar mass is a capital M. Alright, and the unit, this is molar mass, and the unit is going to be grams per mole. It's already said in the definition, 1 gram per mole. So this is molar mass. This is the symbol for molar mass. It's capital M. Okay, so that is the other important thing we have to mention here. Now, something very important to remember. 1 mole of any substance, has a mass equal to its relative formula mass. In other words, the molar mass of a substance is equal to the relative formula mass, and that is the mass that is going to be given in the periodic table. Now, for example, for you to understand this quickly thing we just mentioned, okay? Now, 1 mole of a substance have a mass. In other words, this 1 mole of a substance here, this one here, 1 mole of a substance has a mass. This we're referring to molar mass. This is molar mass. So molar mass is equal to its relative formula mass. Now, the relative formula mass is the mass that you find in the periodic table. This is a relative atomic mass. This one here is the one we are talking about. So, for example, the relative atomic mass for lithium will be a 7. And therefore, that is also going to be the molar mass for lithium. The relative atomic mass, in this case is atomic mass, for carbon is 12, and that is therefore going to be also its molar mass. So the mass of 1 mole of carbon will be equal to 12. The mass of 1 mole of lithium will be equal to 7. The mass of 1 mole of fluorine will be equal to 19. So the molar mass of fluorine is going to be 19. So I hope this one is now quite clear. It's not that difficult. It's just confusing because of the terms are very much the same. Alright, so let's look at one example. This example says how many atoms are there in 24 grams of magnesium and 24 grams of carbon. Now, before that, remember, in 1 mole of any substance, there will be this number of atoms. In 1 mole of no atom particles, but this case, these two has atoms. Magnesium is made of atoms, carbon is made of atoms. So how many atoms are there? It will be the number in 1 mole. So all we have to do is to come here to the periodic table. Magnesium is here. Now, 24 of magnesium is representing 1 mole. Do you understand? I hope you understand this one. So 24 grams of magnesium represents 1 mole, or is the mass of 1 mole. And we know that the number of atoms in 1 mole of magnesium will be equal to the Avogadro's number, which in other words will be 6,022 times 10 to the 23 atoms. That will be the number of atoms in 24 grams of magnesium. Now we go to carbon. Also, we go to the periodic table. Here is carbon. Let's erase that color and use the blue. We're using now the blue. Here is the carbon. We have 12. 1 mole of carbon will have 12. Therefore, 24 is double that number of grams in carbon. Therefore, here will be the number of atoms will be 6,022 times 10 to the 23 times 2, because it's double the amount of grams in 1 mole. Okay, so that will be equal to, when you multiply by 2, you get 1,2044 times 10 to the 24 atoms. Now, another option to do it, which is much better, if I were you, I'll do this one. I'll come to the periodic table and I say, okay, 12 grams will represent 1 mole. 1 mole. Okay? 24 grams, because this is a complete number, it's a whole number, it's easy, but sometimes it's not a whole number. How many moles will be? And then you do cross product. You do cross product here, and you have the 12x is equal to 24. So x, which is the number of mole of 24 grams, will be equal to 24 divided by 12, and it will be 2. So it's 2 mole. And now you multiply the number of moles times the Avogadro's number, and that will give you the number of particles. Okay, we can say that the number of particles is going to be equal to the number of mole multiplied by the Avogadro's number. This is something very important to remember. This is number of particles this is moles, and this is Avogadro's number. And the Avogadro's number is going to be equal to 6,022 times 10 to the 23. Okay, so this is a way of calculating the number of particles. All right, so this is one example for you to see the difference. That is the main purpose of the example, but this formula will help you now to be able to calculate the number of particles. Okay, so this is the very first part of this video I'm making now. The second important part, we're going now to relate these 3 quantities. Okay, so now we're going to relate more quantities here. We're going to relate the number of moles, and number of mole is going to be equal to mass divided by molar mass. This is one of the most important formulas you will have in chemistry. Number of mole is equal to mass, that is the mass of the sample, divided by the molar mass. This is like going backward from here, from this thing that we have marked there. Okay, number of mole is equal to mass. This is mass of sample. Mass of sample. This M is molar mass. Molar mass. Note this one is given in grams, and the molar mass is given in grams per mole. Alright, and obvious the N is the number of mole and the unit is mole. I'm just going to write mole. So now we have 2 very important formulas. One here that relates the number of particles, the Avogadro's number, and the number of mole, and we have another one here that relates the mass of the sample and the molar mass and the number of mole. You can, from here, you can rearrange the formula. You can rearrange this formula, and you will have that the mass is equal to the molar the number of mole multiplied by the molar mass. If you rearrange the formula to calculate M, to make M the subject, or molar mass is equal to mass divided by number of mole. Alright, this is very simple to do, and it's a mathematic rules to do that. Okay, so now we carry on here, and now this one is a very easy work, let's see one example in which you have to apply this formula and the other one. Okay, so let's look at this example. Now this example says calculate the number of atoms there are in a sample of aluminum that has a mass of 81 grams. Okay, now I here copy the part of the periodic table that we need, and that is aluminum. We don't need any other element because we're working just with aluminum. Now here this 27 is the molar mass. We need the molar mass. Okay, now for this question we first are going to calculate the number of moles. Remember, we're looking for the number of atoms. Now number of atoms is going to be equal to the number of mole multiplied by Avogadro's number, which is known, is given to us. So to do this, what we don't have is the number of mole, and therefore we are going to look for the number of mole. Okay, now number of mole is equal to mass of the sample divided by the molar mass. The mass of the sample is 81 grams. The molar mass is going to be 27. So the answer here is 3 moles. So we have 3 moles. Now we have those 3 moles, we can go here and substitute in that formula there. All right, so the number of atoms that we are looking for, number of atom of aluminum, will be equal to number of mole multiplied by Avogadro's number. Number of mole is 3, and the Avogadro's number is going to be 6,022 times 10 to the 23 particles. Okay, so the final answer is going to be number of atoms is going to be equal to 1,80 let's fix the number, 1,8069 times 10 to the 23 atoms of aluminum, working with aluminum. I hope this works. Now the good of the video is that you can pause the video, you can move the video back and rewatch the example, but it's a very simple example here. All right, now let's see another example, a little bit more complicated because we have little bit more substances involved or more elements involved. So how many moles are there in 60 grams of sodium hydroxide? Now remember, sodium hydroxide is NaOH. There is a video where I explain how to write the formula of compound. Please go and watch it. Okay, now here in the periodic table I also cut the part that is helpful for us. We have hydrogen here, we need hydrogen. Let's mark perhaps the whole hydrogen. These are the elements we are going to be using: hydrogen, sodium, and oxygen right here at the back. I didn't copy the whole periodic table. It's not a need for this one here. Okay, now we need to learn, or we need to practice how to calculate the relative formula mass of a compound. We did it before. There's a video for that that you can go and watch. Please go and watch it. Okay, so that one will be the molar mass of sodium hydroxide. So the molar mass of sodium hydroxide can be calculated, molar mass can be calculated by the molar mass of sodium, which is 23. We have 1 sodium plus 1 hydrogen, which is 1, plus 1 oxygen. Let's keep the order there. 1 oxygen, which is 16, plus 1 hydrogen, which is 1. And that answer is going to be 40 grams per mole. This is the molar mass of sodium hydroxide, and it's important. Without that one, you cannot do the rest of the question. The rest of the question is calculate how many moles. So they give you the sample, which is 60. Number of mole is equal to mass divided by molar mass. This is 60 divided by 40. It is 60 here in the question, divided by 40, and the answer is going to be 1,5 mole. That is the question. This question was quite easy. 1,5 moles. Okay, now how many atoms is not part of the question. How many atoms are there in this specific substance? Now be careful, that one will be tricky. Let's write that question. How many atoms are there in 1,5 there in 1,5 mole of sodium hydroxide. Now be careful here. This is a formula unit, sodium hydroxide, OH. Now in this formula unit, in 1 unit, we have in 1 atom of sodium, we have 1 atom of oxygen, and we have 1 atom of hydrogen. In total, here we have 3 atoms. So in each unit, in every unit of sodium hydroxide, you will have 3 atoms. All you have to do is to multiply by 3. So how many atoms are there in 1,5 mole of sodium hydroxide? You come to the first formula. We talk about number of atoms is equal to number of mole is equal to the number of mole multiplied by the Avogadro's number. Now, what is the number of moles here? It's 1,5, but 1,5 is the number of mole for the unit. So we are going to calculate not the number of atoms, we are going to calculate the number of formula unit. I'm going to write unit. How many formula unit we have in 1,5 mole? So this is equal to 1,5 times 6,022 times 10 to the 23. Alright? So we have that in 1,5 mole of sodium hydroxide, we are going to have 9,033 times 10 to the 23 units. So we will have this number of units, but I don't want that. I want the number of atoms. The number of atoms. So how can I get the number of atoms now? In 1 unit, I have 3 atoms. So all I have to do is to multiply this number by 3. So number of atoms will be equal to 9,033 times 10 to the 23 multiplied by 3. And that is going to be equal to 2,7099 times 10 to the 24 atoms. This is the number of atoms in total. Now the question could change. The question could ask, for instance, how many sodium atoms or how many oxygen atoms could be in one of the units. The question can change many times. I cannot give you all the possible options because it's going to be too much, okay? But this is one example of calculating the total number of atoms. Remember, in 1 unit, we have 3 atoms. Therefore, we calculate the number of units and we multiply by 3 to know the total number of atoms we have in this amount of moles they being calculated here in this example. I hope it helped. It's very important and it's the basis of stoichiometric. If we're struggling with this one, then obviously we're going to struggle with more the other work that is coming later on. So we're going to stop here, guys. This is the first video on stoichiometric. This is the basis. In the next video, we are going to be talking about molar volume of gases. We're going to be talking about amount of surfactant, relation with amount of surfactant and molar volume of gases, and maybe we can do some more questions. Later on, we're going to be talking about concentration. I'll try to do the videos today. Later on, I'll make another video related to percentage purity and few things that are quite important for the test. This topic is a little bit tricky and it's a little bit long. So we're going to stop this video here, guys. Thank you. Please subscribe for more. You won't regret it. Subscribe for more. I will post more videos that can help you for the upcoming test. And it's not only for the test. If you are in grade 10, remember this topic is going to be used in grade 11 as well as in grade 12. So thank you for watching. I hope it helped and I'll see you in the next video. Thanks a lot.